SMX has an industrialized patented technology. We can mark and trace any kind of plastic: high-density polyethylene, low-density polyethylene, polypropylene, PET, PVC, polyurethane, and more. We know how to mark monomers, virgin polymers, and plastic waste. The technology can accurately identify the producer ownership and material composition within any plastic article, whether it's car parts, electronic devices, bottles, synthetic fibers, and packaging, enabling it to re-enter the economy for recycling and reuse. This is all can be done by three main components of SMX: chemistry, physics, and software. In the chemistry, it is based on a chemical-based hidden marker system that can be applied into the liquid monomers or the solid polymers. In melt processes, for example, for virgin or recycled plastic, we supply the marker master batch that is then melted and mixed together with the polymer resin during the compounding or the product manufacturing process, so that eventually the embedded marker system is dispersed homogeneously in the resin and holds irrefutable data. The data can be a qualitative data or a quantitative data on the material itself, and this is at any stage of the value chain. Thus, it can remove any blind spots and ensure an unprecedented transparency of information and supply chain. The second component is the physics, which are a unique patented reader that is designed to read the embedded data in the material or the product within seconds, without having to alter the product. And the last component is the blockchain, the digital platform that record, store, and verify ownership of data. Scans from the reader that receives response signal from the product itself are recorded on the platform and ensuring the highest level of data reliability. This all proven technology offers some key benefits for the plastic industry. First, it increased the total amount of recycled material that is eligible for reuse. By giving material memory, we allow waste that is currently not recycled to re-enter the industry. Second, we can increase the quality of post-consumer recyclate, and this is by allowing sorters and recyclers to operate advanced sorting. They can segregate waste by grade, if it's food versus non-food contact, by brand, by application, and any type of sorting. It can also help brands to avoid the plastic packaging tax, and as a result of increasing the content of recycled material in their products. And this tax already came into force in the EU and the UK. And lastly, eventually, which is most critical, this will lead to less amount of virgin material that needs to be produced, which is the key for more sustainable and circular value chain. We present to you today one use case of circularity we did in Canada on recycled high-density polyethylene. The goal of this project, the ResiChain project, was to prove that the circularity, the action of maintaining a product value through the product life cycle and into a new product, it's something feasible, it's cost-effective, and can be enabled through recycling by SMX marking system. So in the example of front of you, recycled high-density polyethylene was marked, which gave the stakeholders a proven ability to authenticate the actual loading of the recycled high-density polyethylene in a product and trace the movement of the bottle along the value chain, from raw material to product, from product to commercial, and from commercial to recycling and reuse. We, together with all the stakeholders, defined some 4 key features that the chemical marker should hold. One was the type of the plastic, which is high-density polyethylene, the producer, whether it's the bottle producer or the brand, the percent of recycled content in the bottle, and the last feature is the number of times or loop the plastic has been recycled, because it affects the quality of the plastic. Now, if we briefly go through the different stages, as I mentioned previously, the marker master batch is produced by SMX and was supplied and sent to the recycler to be added during the recycling phase, so that the outcome marked post-consumer recyclate was scanned using the SMX scanner, and all the related data on the material on the recycled high-density polyethylene was stored on the blockchain platform. The marked post-consumer recyclate was then sent to the bottle producer, and the actual percent of the recycled HDPE and the loop count in the bottle itself was verified by SMX scanner, and again, upload to the blockchain record, so that the movement of the marked bottles along the value chain was recorded, so that at the end of the product lifetime, when it's no longer a product, it becomes a plastic waste, all the information of the type of the plastic, the percent of recycled content, the loop count, and the producer have kept. This information can then be used for advanced sorting, as I mentioned earlier. It can improve the quality of recycled plastic, and again, eventually, to get to the holy grail goal of producing and consuming less amount of virgin material. This is only one example out of many how SMX is marking and tracing raw material, and we can give material memory to become a more sustainable supply chain.